Black holes. They lurk unseen and hungry. Could there be black holes small enough to be close to planet Earth and go completely unnoticed? If the Milky Way can have millions of these intriguing objects, then why are they so difficult to detect? Let's try to understand more about it. The first theoretical predictions about the existence of black holes were made by the German mathematician Karl Schwarzschild in 1916, shortly after the publication of Einstein's theory of general relativity. Schwarzschild was the first to calculate the exact solution to Einstein's equation for an infinite mass spherical structure, which is now known as the Schwarzschild solution. In the early 20th century, the idea of black holes was viewed with skepticism by many scientists. Although Einstein's theory of general relativity had predicted the existence of black holes, many believed that they were mere mathematical curiosities without any practical relevance. Additionally, the idea of a region of spacetime where the laws of physics do not apply was considered difficult to accept. Schwarzschild's solution showed that the presence of a sufficiently large mass could cause such a sharp curvature of spacetime around it that no matter or radiation could escape. This was called the event horizon, and it is what defines a black hole region. Schwarzschild also showed that the region within the event horizon is a singularity, where known laws of physics do not apply. Although Schwarzschild was the first to make these predictions, he did not call this solution a black hole. The term black hole was later coined by American physicist John Archibald Wheeler. Despite initial skepticism, some scientists continue to study black holes and seek evidence of their existence. The discovery of X-rays emitted by stellar sources in the early 60s provided the first observational evidence for the existence of stellar black holes. This was followed by the discovery of supermassive black holes at the centers of galaxies and the detection of gravitational waves generated by black hole collisions. But what are black holes really? Black holes are extremely dense celestial bodies with strong gravitational attraction power. They typically result from the death of very massive stars that exploded when they consumed all their fuel and left behind a nucleus whose density is so great that it collapsed into space-time. As they do not emit or reflect light, and nothing can escape their gravitational pull, black holes are invisible. However, we can detect them through the distortions they cause in the gravitational fields of stars and other celestial bodies, or by observing their accretion disk, which is a disk of pulverized matter that is spinning at speeds close to light and that heats up so much that it emits energy and radiation, which we can detect from Earth. Black holes have extreme gravitational pull, and once anything, even light, crosses the boundaries of their event horizon, it can never get out. Hungry, they are capable of attracting and destroying even gigantic stars, feeding on the material that forms them. And since it feeds on matter, it increases in mass and power. The photo that changed everything. Although our current technology can detect the energetic emissions coming from black holes, it was crucial for science to be able to see one of these monsters in a clear and distinct way. And this finally happened recently when the Event Horizon Telescope, EHT, an international consortium of telescopes, managed to photograph the black hole at the center of galaxy M87 in 2019. The image shows a bright ring around a dark region, known as the event horizon, where the gravitational attraction is so strong that nothing, not even light, can escape. The bright ring is caused by radiation emitted by the hot and luminous matter that is being attracted into the black hole. The photo was obtained from data collected by 9 radio telescopes from around the world, including the Atacama Large Millimeter Array, ALMA, in Chile, the South Pole Telescope at the South Pole and the James Clerk Maxwell Telescope in Hawaii. The data was combined using advanced image processing techniques to produce the final types of black holes. Black holes can be divided into 3 categories: stellar black holes, supermassive black holes, and intermediate mass black holes. Stellar black holes are the smallest and most common, formed from the death of a star. Supermassive black holes are found at the center of galaxies and can have masses of millions or even billions of times the mass of the Sun. Intermediate mass black holes would be black holes whose mass would be too large to be stellar black holes and too small to be supermassive. But, although there are clues of the existence of this type of celestial body, it has not yet been possible to observe the existence of intermediate mass black holes. A 4th category of black holes, hypothetical, would be the primordial black holes. The theory of primordial black holes suggests that these black holes would have originated shortly after the Big Bang, from quantum fluctuations in the initial structure of the universe. They can have masses of several tens of times the mass of the Sun, or even billions of times the mass of the Sun, and may have given rise to very small and undetectable black holes. Small, dangerous, and hidden. As many theories predict the existence of small black holes, whose detection is extremely difficult, it would not be impossible that one of these celestial bodies could actually be close to the solar system. Scientists remain attentive to any gravitational disturbances in the structure of our solar system, in order to detect the presence of strange bodies that interfere with the orbit of the planets, moons, and asteroids that surround us. On the one hand, while we are still able to detect small black holes in our neighborhood, on the other hand, the cosmic giants are much easier to find. Supermassive black holes are extremely dense and large black holes with masses of millions or billions of times the mass of the Sun. They are found at the center of galaxies, including our own, the Milky Way. Supermassive black holes are responsible for many of the important events in galaxies, including star formation and the evolution of cosmic structure. Their existence has been detected through the gravitational effect they exert on nearby stars and planets, as well as through the radiation emitted by the hot and luminous matter that is attracted into them. Recent studies have also shown that supermassive black holes may have an important relationship with galaxies and their evolution. They can influence star formation, matter clustering, and the formation of cosmic structures. Research on these black holes is also helping to better understand fundamental physics, including general relativity and quantum mechanics. King of the universe. Although measurements of the sizes and masses of black holes are an evolving science, it is possible to estimate the mass of these celestial bodies through their gravitational influence on objects around them. These data are always changing and updating, but up to the publication of this video, the largest known black hole is a monster known as TON 618, classified as a quasar, located in the constellation Canes Venatici 10.4 billion light-years from Earth. According to more recent studies, TON 618 would have approximately 66 billion times the mass of the Sun. In summary, little is known so far about these curious objects that are capable of overcoming even the speed of light and can be dozens of billions of times heavier than the Sun. But they have caused fascination and curiosity for Earth's inhabitants for more than a century, since Einstein predicted their existence. With the evolution of new telescopes and direct and indirect forms of observation, scientists will certainly find many answers to this mystery in the near future. Thanks for watching. If you like this content, consider subscribing to the channel. See you soon.